So before I introduce Rachel Connolly and Keith Mountain, let's just have a round of applause for sustainability at University of Louisville. Great, thank you. Okay, so we're going to kick this day off by having a little introduction by Rachel Connolly and Keith Mountain to the core issue of climate change. And Rachel Connolly is the director of the Planetarium here. She's been here a little more than a year and a half, I believe. She's a faculty member in the College of Education. And previous to coming to U of L, she was the astrophysics education manager at the American Museum of Natural History. So she has a lot of experience and a lot to offer U of L. We're glad she's here. And Keith Mountain, most of you know, he's a professor and chair of the Department of Geography and Geoscience. He was recently appointed the state geographer for the Commonwealth of Kentucky. He did not wear a green tie today, but we're going to give him a bye on that one, because as a climatologist with a specialty in glaciology and global climate change, he's been a part of more than 25 international expeditions. He's probably got really warm weather wear, that's what I could say. He's been on more than 25 international expeditions to study existing glaciers and ice sheets to really understand the Earth's climate history. Without further ado, I want to introduce Rachel Connolly and Keith Mountain.
I'm actually going to be doing my presentation from the back. We're going to take this opportunity to use a brand new planetarium technology that you're going to be seeing called UniView. And everything you're going to see today is real data, satellite imagery, and I'll be driving it live. So if I run into a planet, I apologize, okay? And Keith will be our wonderful guide here for the state of climate right now globally. So I'll move to the back.
Right. Well, thank you all very much. What a wonderful opportunity to be here and to be part of something that is very, very important. I'm sure that we can all appreciate, which is why we're here, that in effect global climate change and understanding our global climate system is the most pressing scientific issue of our time. It embodies everything that we know about our planet. Every geophysical, biophysical process that exists owes its existence to this very delicate climate. And we've become rather used to it. And so one of the things that we would like to appreciate is that climate change is really quite consequential to us and consequential to all of us, not just for now, but also in the future. So when people suggest that you are following or why are we interested in ice sheets and glaciers as they existed in the past, it's because they are telling us something about our climate right now, and they will surely tell us something about our climate future. And as we are now, as humankind, are more engaged as an agent of global climate change and global Earth surface change, it is very important that we understand who we are, what our impacts are, and that will give us a good measure of a guidance for our sustainable future. What sort of world are we going to hand over? And I would point out very quickly that what we observe in the climate record is that these changes are taking place right now. They are occurring very quickly. The idea that climate change is something that is going to occur beyond your lifetime and start to be manifest at some point is quite incorrect. Even within the short period of time of my 25 or 30 years of working in the glaciological field, we have seen enormous changes. And these are connected to the climate. So this is a real issue. It is a contemporary issue. So between Rachel and myself, we would now like to use some of the remarkable technology that University of Louisville has cultivated and offers to both its students and the community, just to have a brief look at travel around the world. Why not? It's there. It's our world. All right, Rach, if you would please. So what we have, let me take that. So what we have here is one of the great indicators about climate change is the sea ice changes that take place in the North Pole. And why is this important? Well, it's a big temperature, it's a big thermal regulator of the northern hemisphere and, in effect, the global climate system. And so what we are seeing here over the last 20 or 30 years is this enormous change in the pack ice in the Arctic. And what you're looking at here is the months of the year swinging by since 2005, and you're starting to see what it means as a seasonal pulse. This magnitude of this sea ice reflects solar radiation. With it missing, we would see an entirely different temperature structure between the equator and the North Pole. And you can start to see where we are now relative to where we were not so long ago. And this is enormously consequential. So there's our summertime, our conditions. Pretty much right now, we're losing on the order of about 10% per year of this ice. And it's not just losing it in terms of its spatial dimensions, it's also thinning. Surprisingly, the Arctic sea ice is on the average only 3 meters thick. And now icebreaker, for example, can easily charge its way through that ice. So if we're losing this at this particular rate, and we're able to observe it now with some of this remarkable technology, we can have real-time observations with this very precise calculations. So we are able then to understand the role of this particular phenomena as an agent of global climate change or as a reflector of it. So the Arctic to us is very, very critical.